Okay, hello everyone. My name is Martha Guerin, and I'm one of the account managers at Atmosera for training. I want to introduce you to Ron Sumida, who's going to be our instructor, and Mike Hacker, who is our guest speaker real quick for Microsoft. To give you a little background on Atmosera, we are a Microsoft partner. Our headquarters are in Portland and in Atlanta, Georgia. We work closely with the Microsoft teams and align with a few of their core practices, including DevOps, app modernization, app development, Azure infrastructure, and data and AI. And we also have a training arm, which is where Nicole and I work. We do a little bit of everything. We do all the Microsoft certifications. We do Docker, Kubernetes, DevOps, and pretty much anything you can imagine. We also have a managed services arm on our team, and they are strictly an Azure Microsoft managed services excellence team. So I'm going to hand it over to Mike, who's going to take over from Microsoft.
Good morning, good afternoon, everybody. First off, I'd like to thank everybody for joining us today. This is a great webcast series that we're going to be doing today. And to kind of kick it off here, I just want to introduce myself really quick. So I'm an Azure App Innovation Specialist for Microsoft State and Local Government. I've been with Microsoft for about 13 years and been in the software development field for over 30 years. And on the screen there on the left, you'll see my email address and a blog that I have. If you have any questions for Microsoft, feel free to email me directly. And the blog there, I have some great technical training information that you might want to check out. Also post upcoming events and that type of information out there. So I definitely go check that out. Now, this webcast series is around container and container technology. And when we were really originally kind of coming up with this idea, we were trying to decide what would be good topics to help everybody kind of get started. So we want to start kind of at the basics with container technology. And the reason why we're focusing on container technology really is this first bullet point, is that a global survey was done of about 819 or so organizations, and they said about 89% of them said that container technology and containers in general was either a strategic direction or will be playing a strategic direction for them in the future. And so we're seeing this across the board with our customers wanting to modernize applications by using containers or build new microservices-based applications on containers. So we figured this would be a good way to kind of get everybody, get their feet wet, learn a little bit more about the basics, starting with Docker, and then eventually learning a little bit more about things like Kubernetes. Now, a couple of quick things. One is this is not a sales pitch. This is definitely a technical conversation. But I do want to throw in a couple quick things on the Microsoft side real quick. So one is that, of course, Microsoft provides a wide range of technology solutions for both creating, your building, deploying, hosting your container applications. So if you're interested in learning more about that, reach out to your Microsoft team. We also have a wide range of technology trainings that are available on our Microsoft Learn website. So docs.microsoft.com/learn. If you've not been out there, definitely go out there and check it out. You can learn more things about Kubernetes, about Docker, and also other wide range of Azure and cloud-related services. And then, of course, if you have any questions or you want to dive deeper into anything, reach out to your Microsoft account team. Each of you should have a Microsoft account team that you can reach out to. If you don't know who they are, please reach out to me and I'll get you connected. And they can really help walk through that application modernization discussion with your teams and help you kind of pick and choose what makes the most sense for what you're trying to accomplish. And then, of course, reach out to Atmosera to learn how they can also help you on your container journey with the services that they offer. So with that, I'm going to go ahead and turn this over to Dr. Ron Sumida.
All right, thanks. So here's what we're planning to talk about in this talk today. We'll first look at an overall introduction to Docker. We'll talk about why you might want to use Docker and the motivation behind it. We'll then look at containers, which are the fundamental building blocks for Docker. An important aspect that you should know about when you're going to work with any technology is really the architecture of that technology. So I want to talk a little bit about the architecture of Docker as well as the architecture of containers in general. And then I'm going to, from the ground up, start with an Azure Ubuntu VM and install Docker into it, show you some of the basic commands. Of course, I have to talk about images. If you're at all familiar with container technologies, you know that images are a big bit of what you need to know about for working with containers. So we're going to be looking at images, You will see how to share images through Docker Hub and also the Azure Container Registry, the ACR. We'll talk briefly about that. We'll look finally at the end of this is the culmination of everything, look at how to take a simple hello world Node.js application and deploy it into a container, basically Dockerizing it, and that involves knowing about a Dockerfile. So we'll be talking about some of the fundamentals of that, and then we'll ultimately run the container from the image. So that is the plan over the next couple hours for what we're looking to cover. So let's start from the beginning of what Docker is and what it represents. It's basically an open platform for managing applications, and it helps streamline the development, the shipping, and the execution of your software. A big aspect of Docker is that it separates the application from the infrastructure, but yet you manage both the same way. And a big advantage of using Docker specifically and containerization in general is that it'll help you minimize the time between development and production. And another advantage is it provides efficiency and predictability to your development lifecycle. In other words, it makes those common configuration tasks that you might have relatively easy. And given how important and ubiquitous the cloud is now, of course, Docker supports the cloud, but you can use it locally on the desktop as well. So this is a term you'll hear quite a bit when you start working with Docker, is the term container. And what is a container? Well, it's an environment for packaging and running an application. And I view it as the lowest level atomic units that you work with when you are working with Docker. And you, in a container, package everything that's necessary for the execution of your application. And a big advantage of containers is that you're not dependent on what is installed on the host. So you're going to package up your application, any dependent libraries, any other applications that you need in order to run your app, that can all be packaged into a container. And the container represents the unit of distribution and testing. It provides isolation and security, and it enables you to basically run multiple containers on a single host. And the lifecycle of a container, if you're using Docker for containerization, is managed by Docker through what is provided for you with the platform and the tools. So these are some of the big benefits of containers. I've been alluding to this over the last couple of slides, but here it is more formally, some of the biggest benefits that you would have for containerizing your software. One big benefit of which is standardization. So you can develop with local containers, but as I mentioned a moment ago, you can deploy those local containers ultimately out to the cloud. And it really does remove a lot of the operating system or platform dependencies when you containerize. And a big buzzword that you hear these days is CI/CD. So given the fact that people who are doing any sort of development these days on a relatively large scale, they're all looking to do CI/CD. So they want to be able to develop some sort of pipeline for automating the development process, and containers facilitate that. To me, one of the biggest advantages of containers is portability. The fact that, and I mentioned this a moment ago, but this is one of the points I really want to drive home. The fact that once you containerize your application, then you can run it locally or in the cloud in basically the same way. And you can run on a physical or a virtual machine. So you're basically removing all of those operating system platform dependencies that you would otherwise have. And just to give you a little bit of an anecdote, there's this friend of mine who is a software developer who's gotten really, really into microservices. And I was talking to him about Docker and Kubernetes, and his feeling was, well, we don't need Docker, we don't need Kubernetes, we have microservices. One of the big arguments I made to him is, well, one of the problems with microservices, as appealing as they are, is you don't have the same level of portability. For example, he's working with AWS, and if you want to take your AWS deployment with a microservice and port it over to Azure or some other cloud service, it's not so easy to do that. With containers, you can basically, once you containerize, take that container and put it right onto whatever cloud platform you want to work with, or you can run locally as well. And like I say, you can run on a physical or a virtual machine. Another advantage of containers is if you use services like Kubernetes, for example, scaling. The fact that you can scale up or down in near real time, if you have something that helps manage the containers for you. And containers are very lightweight. They are much cheaper than using a virtual machine. And a lot of these aspects that we're talking about with containers seem like they're very similar to virtual machines, but I'm going to show you an architectural picture coming up, which will give you an idea of why I say that containers are so much lighter weight than using a virtual machine, which is another huge advantage of working with containers. And this is actually that picture right here. And I always like to give attribution for where these pictures come from. So I'll take you to the actual documentation page for where you can see that picture that I put onto this slide. It's actually not the Docker documentation, it's the Kubernetes documentation, but this still equally applies. And what this diagram, the diagram is the key part of it at the bottom of the slide there, what this shows is the traditional deployment way that years ago people used to deploy their apps onto their hardware, where they would have to go and acquire the hardware, install the operating system on it, and then their apps run on top of that operating system, which in turn is running on the hardware. Then you had the big virtualized deployment era where people got really into virtual machines. And with the virtual machine, you can have multiple virtual machines running on a single piece of hardware, for example. And the big problem with virtual machines, though, is that you would have to install the operating system separately into each one. And then, of course, any libraries that your applications would use would need to be installed onto that virtual machine, and your apps would run on top of that infrastructure. Now, looking at the difference between virtual machines and containers, which is the difference between what you see in this middle box on the slide versus what you're seeing on the right-hand side of the slide, the biggest difference to notice is that with containers, you are not installing the operating system into the container, unlike the way you install the operating system on a VM. And that is the #1 item that makes containers so much lighter weight than virtual machines, the fact that you do not have to install the operating system into it. And the benefit of this type of deployment scenario is that now you can have all of these containers running on top of a single OS installation, as you're seeing on the right-hand side of this picture. All right, so bottom line of containers is that they are a lighter weight alternative to virtual machines. They are smaller, less expensive, and therefore they start up faster, but yet they are still self-contained. So looking at the architecture of Docker, here are the main pieces. There's the client, which communicates with something called the Docker daemon, and that Docker daemon provides support for the containers and the images. And the image is basically a template that has instructions for creating a container. I'm going to talk more coming up about the architecture of an image and how it differs from a container. And then there's the registry, which is the repository for storing images. Now, if you look at the title of this talk, one of the terms that I used was that it's not only about building containers and images, but it's also about sharing. And through the registry, you can actually share images as well, right? Which is something that I'm going to be showing you in the course of the demos that I'll be doing coming up. As always, I like to show some sort of architectural picture to make this more concrete. And here's the critical picture that shows you the relationship between these 4 items. And once again, I always like to give attribution to where these pictures are coming from. And this also helps you get oriented if you're new to Docker with the documentation. So I'll just click on the link that I put at the bottom of the slide there for where you can go to the page for the Docker overview, which describes the Docker platform, talks about what you can use Docker for, and then goes into a very high level picture of the Docker architecture, and that's what I'm presenting right here. So those major pieces that I mentioned a moment ago, let's start with the right-hand side of the slide with the registry. This is the place where people can create their images, share those images with other people by putting it up to a common registry. And if you don't want to share it with everyone, then you can create basically your own registry that is private so that other people cannot get to it. But you can also make it public so that you can share it with everyone out there in the entire community who is all using Docker. Notice also that you have your Docker host with the Docker daemon that I described a moment ago. You have your containers and your images. The containers are basically based on some form of an image, right? You run a container based on an image, and that's the process that I'm going to be demoing to you coming up, is how to create an image, #1, how to run a container based on an image, #2. Now, in order for you to interact with Docker, you need to install it, and I'll take you through the installation process as well coming up. And these are some of the main commands that you might run with docker.exe. So to build an image, you run docker build. If you want to pull an image from the registry into your local cache, you can run the docker pull command. And if you want to run a container from an image, the command you would execute is docker run. And I'll be showing you and talking about these main commands coming up in the demos that I'm about to do. When you run these docker.exe commands, you're communicating with the Docker daemon. The Docker daemon, in turn, if you're referencing an image, is going to pull that image from the local cache. If it's not there in the local cache, it will download it from the registry, put it into your local cache, and then you can, if you run Docker run, for example, create a container based on the image. So this is the key architectural diagram that ties together these four main pieces that were mentioned on the preceding slide. So looking at these pieces in more detail, there is the client, which is implemented by docker.exe. And if you are installing Docker on Windows, and there is something called Docker for Windows where you can do a direct installation onto your Windows box, then the place where the Docker executable resides is in C:program files. In fact, let me show you the real thing, because I do have it installed on my machine, a local Docker installation. So I'll show you that right now. If you go under C:program files, so right here, and once you've installed Docker for Windows, then you'll have a Docker folder underneath there. Then if you go underneath the Docker folder from there, this contains some of the critical bits of the Docker for Windows installation, including the Docker desktop.exe. And for right now, what we're talking about, though, is in the resources folder, there's a bin subdirectory. I'll show you that right here. And then you're able to see docker.exe. And to show you, if you are interested in doing a direct Windows install, I'll take you to the web page for Docker for Windows, which is right here. This is the place to go. Notice that this is on a Docker docs page, and this allows you to install Docker Desktop directly onto Windows. I'm actually not going to use that for this talk because I actually want to show it to you from Linux as an alternative. And with Linux, once you do the install, it'll be in user bin. And this is the primary method. Either way, no matter how you install docker.exe, it is the primary method for you to interact with Docker from the command line, and it sends Docker API commands to the Docker daemon. Right? So ultimately, you're really under the covers using the Docker API, and you can use that either directly, programmatically, if you would like, or more conveniently, install docker.exe, and then you can talk to the Docker daemon, which will in turn execute the Docker API commands on your behalf. Speaking of the Docker daemon, this is implemented by a program called dockerd.exe, and the location for that is in the resources folder if you're installing this onto Windows. So if I go up one level, you should be able to see dockerd.exe here, right there, it is. And then again, under Linux, it'll be in the user bin folder. And this listens to the Docker API request. It creates and manages your Docker objects, and it communicates with the client and the other daemons as well. And the client to daemon communication can be done through a REST API directly if you would like, or more conveniently, like I say, you typically use docker.exe. That communication can be local or remote. It can be one-to-one or one-to-many, and it can be performed through Unix sockets or a network interface. So those are some of the possibilities for that communication. Back to the architectural diagram between the client here and the Docker daemon. So I don't want you to be misled by this diagram into thinking that the only way to do that communication is by using docker.exe. There are a number of other options, as we're alluding to on this slide. Now, I've been using this term image up to now, but I've never really formally talked about it. And here's a good place for us to talk a little bit about what an image is, but I'm going to certainly go into more detail coming up. And a Docker image is basically a template that contains the instructions for how to build a container. Now, an important thing to know about a Docker image is it's composed of a bunch of read-only layers, and the keywords there are read-only. An image is typically based on another image. Any image you create will be based on another image, and in order to create a new image, you typically do that with a Docker file. The file that has to be called Dockerfile. And by the way, and you'll see this in the demo that I'm about to do where I'll create one. In fact, that'll be the culmination of everything when I create a image of from a Node.js application where I'll involve a Docker file to do that. Very key thing to remember, the D in Dockerfile needs to be uppercase, and yes, it is case sensitive. So I talked about the registry a moment ago, but here's a bit more detail about it. The registry is a server-side application for storing and distributing images. It is stateless, highly scalable. It can be either public or private, and the primary registry for Docker is called Docker Hub, which is a public registry that contains over 9 million container images. So this should give you a pretty good idea of the popularity of Docker and containerization, given the number of images that are out there. And I'll be showing you Docker Hub coming up, where you'll be able to see how many images that are out there. And this is the default location where if you want to search for an image, given that a big part of what Docker is about is being able to share images that you create with other people, and that sharing is typically done through Docker Hub, then this is the centralized place that you would go to in order to find what images are available. And I will tell you, most of the big name bits of software that you have likely been working with or want to work with in the future are very likely up there in Docker Hub. All right. So there is the Docker engine, which is a client server application that's composed of the daemon, which is Docker D, which I mentioned a moment ago, the Docker API for communicating with the daemon, and then the Docker CLI, which is that docker.exe that you can use from the command line. The platforms that you can use for working with the Docker engine are Linux, the Mac OS, and Windows 10 with Docker Desktop or Windows 11. You can install Docker Desktop directly onto it. And now let's get into the installation so that I can finally actually start to demo to you how to work with docker.exe and ultimately how to build an image and how to create a container based on that image. There are several different installation options for installing the Docker engine on Ubuntu. One option is you can use the Docker repository. Another option is you can use, for example, a Debian package, or another way is through a convenient script. If you want to know more about these options, then once again, I'm linking the doc page at the bottom of the slide there that you can go to for getting the details of how to install Docker basically onto, in this case, specifically an Ubuntu scenario. And what I'm going to do for this talk is I'm going to create an Ubuntu VM using Azure. So let me get to my Azure subscription right here, where I'll just click on create a resource. Since I want to do this demo from the ground up, that's why I'm creating it right out of the box so that you know I'm not starting from anything initially. And then I'm going to choose this one, which is Ubuntu Server 20.04 LTS. So let's click there. And on this blade where it asks me to give them the details of the virtual machine I want to create, I'm going to specify the resource group name that I want to use. I'm going to call this SLG demo-rg. I usually follow a convention just personally of putting the -rg suffix on the end of resource group names that I create. By no means is that universal, but that's just so that I can keep them straight. For this virtual machine, I'll call it SLG demo. And for the region, normally I advise in terms of a region selection, choosing a region that's geographically closest to where you are. I am right now in Birmingham, Alabama at a client of mine where I'm working on a B2C consulting project for them and also teaching Azure AD B2C for them as well. So I'm going to choose South Central US, which turns out to be one of the best regions I have found personally in terms of the data center very often tends to be more lightly loaded than the major ones on the east or on the west coast. I live in Los Angeles, so normally if I were doing this demo from there, I would choose West US or West US 2, but I'm choosing South Central US for the reasons that I just cited. I'm going to take all the other defaults on this blade, with one other exception though. Instead of using an SSH public key, I'm going to use a password. So I'm just going to click on password there. I'll specify a username of Azure user, and then I'm going to put in my password. I'm going to use to SSH into this Ubuntu VM, and then everything else I just want to stay with all the other defaults. So I'll click on review and create. Hopefully we pass validation, and then I can go and create an instance of this VM. And usually this is pretty quick. I ran afoul of something on the networking side. Let's see. What didn't it like? So subnet basic. That gives me a whole lot of information about what it didn't like. Let me try it again. See if it'll give me more descriptive info. Oh, okay, no, that's some phantom error because I just clicked on review and create. It looks like it passes validation now, and I'll do a create, and we should be good to go. This usually is pretty quick. I know some resources in Azure take a while to create, but this one I've had pretty good luck with when I've done this demo in the past, where within a few seconds, usually it's spun up and ready to go. There's a class I used to teach on Azure infrastructure a few years ago, and some of the things, some of the resources that you create there, I'd have to spin them up in advance. It would take like 45 minutes before they're fully up and operational. But this one, as you see, it's already ready to go. I'll click on Go to Resource, and then I'm going to click on Connect, SSH. And the only piece of information I really need to get out of here is just this part, which is basically my IP address. Now, there are many different ways that I can connect to this Ubuntu VM through SSH. One is I can bring up a standard command prompt. Two, there are a lot of tools out there, but I'll tell you my favorite one. My favorite one is to use Windows Terminal. So if you have not worked with Windows Terminal, I would strongly encourage you to have a look at this, because this has really transformed the way that I do command line work on Windows to a level where this is my default go-to command prompt that I work with when I am doing any sort of command line work, with one exception. The only time I don't use this for command line work is when I'm doing .NET related work where I need the Visual Studio command prompt, because it sets my path to all the Visual Studio related tools that I need by default. But one of the things I love about this is that it's so well executed, but also if you pull down this drop down right here, you can see there's a range of options where you can use it with Windows PowerShell, Ubuntu, because I have Ubuntu app installed, as a straight command prompt. So I just want to make you aware that there's a lot of really good options here that you might want to at least have a look at if you're not familiar with this Windows terminal. All right, I'm going to SSH in to the Ubuntu VM that I created a moment ago, putting in my password there. And I may not have typed that in properly yet. All right, let's have another go at it. And there we are. Now we're in. All right. So initially, this Ubuntu VM we're creating one entirely from scratch. Nothing is going to be installed on here with relationship to Docker. But now I'm going to show you the installation process for getting Docker into that Ubuntu VM. And the way that I'm going to look to do it is to just execute these commands that I put onto the slides. I just summarize them on the slides so that I can quickly do the installation and then get going on this demo. First step would be to uninstall any existing versions. Well, I know I don't have any existing versions out there, but just as a best practice, I typically like to go through that step just to be sure that I'm getting rid of anything, any weird stuff that might be there from before. Although having done this many times with this Ubuntu VM, I know that there's not anything already installed to begin with. But just to show you, if you were walking up to some existing Ubuntu VM that you might want to have, you may want to execute this command first to remove any previous installations. And then after that, next thing to do, because we're using apt to do the install, then advanced package tool, then I'm going to execute apt-get update, and I'm going to use the sudo command so that I'm running that basically as admin. And then after I execute that, to do the update of the package index, which usually takes a couple of seconds. Then the next step is to execute this command to install the packages for setting up a stable repository over HTTPS. All right, so that last command finished, I'll execute this command. And once that's done, then the next step is to add the official Docker GNU Privacy Guard, or GPG key, which is used to verify the integrity of the software. I'll go ahead and grab that command in preparation for running it like this. And then the next bit is to set up the repository on x86 64 or AMD 64, which would be to run this command that you see right here. Right? And there we go. Paste that command in and run that one. And then the next bit is to now run the same command again to update the apt package index. And once that finishes running, then now I'm finally ready to install the bits of Docker, the latest version of the Docker image. So this is the critical command right here. All that other stuff was just preparation for executing this command to install Docker and the bits of Docker that I need. So really a Docker installation only takes a couple of minutes like this if you know the right commands. And once this finishes, then we'll basically have Docker installed. One of the first things that I like to do once the installation completes is to check the version of Docker that I have installed by running the Docker version command. So as soon as this comes back to me after a few more seconds of downloading pieces, then I'll be able to run that Docker version command. And it's important to know a little bit about the version you're running versus the latest version that's out there, because when you do the installation fresh like I'm doing right now, I don't really have to worry about whether my version's older because I'll have just installed it. But as you work with the installation of Docker over time, you might get to a point where there's newer versions of Docker available, and then you need to know, well, how do I update my existing version to the latest? So we'll be talking about that in a few seconds as soon as this last bit finishes here. All right, well, because I never like to sit idle just waiting for some installation to finish, let me talk a little bit more about what I'm going to run next. We're going to test the Docker installation by running a hello world image that's already there. And then we're going to check and query the available versions by running this command, which is the apt cache Madison docker-ce command. Then I'll show you where you'll be able to see the version strings. And then if you find that your version is not the latest after running this Docker version command and then running this command here, then what you can do is run the command I put at the bottom of the slide there to install a more updated version from what you might have. All right, that installation now did finish. I am equipped to run Docker version, like I was mentioning. This allows you to see the version of Docker that you are running. And then here's the other command that I was mentioning a moment ago. We'll run this sudo apt get update command one more time. And then after that completes, we can come in and run this command, which will tell us the versions, the latest version. And now you're able to see the very latest one is this one, 20.10.17. And if you look back up at the history of what I ran a moment ago, when I ran Docker version, that is the very version that I have installed. So therefore I can tell that I'm on the latest one. All right. And like I said, if you find you're not on the latest one, you want to get on the latest one, run the command that you see at the bottom of the slide there. Now to test your Docker installation, you can run this command right here, which is sudo, then docker run, and then hello world.exe. So I'll just put that in, run it, and this now displays the hello from Docker. This is the hello world. This is the result of running that Docker container, creating a Docker container based on the hello world image and running it. And the result of that run is what you are seeing here. So once you get to here, you know that you have a good Docker installation. Otherwise, you would have gotten some error when you tried to run this sudo docker run hello world command that you see there. All right. So at this point, we have everything installed that we need for being able to work with Docker, which is that docker.exe along with the Docker engine. Now, in order for accessing Docker, it's inconvenient to have to run the sudo command every time you want to run a Docker command. I mean, about the only command I'm able to run without needing sudo is Docker version. You saw that I was able to run that one straight up. But in these other commands, in fact, let me show you what happens if I try to run some common Docker commands that I'll be talking about in detail in a few moments, like Docker PS, for example, which shows me a list of the running containers that I have. When I run that, see how I get this permission error, that I got a permission denied while trying to connect to the Docker daemon socket. The problem is that I have to use sudo if I want to run these commands by default. So if I use sudo in front of it, then now the command runs successfully. You see that I have no running Docker containers right now, but that Docker PS command would list them. But that's not the point for what I want to talk about right now. The point is that I have this issue of always having to prefix every Docker command that I run with sudo, and that's inconvenient. So the solution to that problem is what is outlined on this slide here, that there is a way for you to set up a group, a Docker group, and then add yourself to that Docker group so that you no longer have to run that sudo command. Now, as it turns out, with this Ubuntu installation that I did, and with installing Docker onto it, the group is already there. If the group weren't there, then you would have to create the group. But you actually don't have to create the group. if you're on an Ubuntu VM and you've installed Docker the way that I showed, let me show you that the group is there. I can go to etc. and then group. In fact, I'll just cd to etc. first, and then cd / etc. And then if I look at, if I cat the group file, at the very bottom, you see Docker right there. So the Docker group's already there. That I don't have to do. What I do end up having to do, though, to avoid having to do that sudo command, is just add myself to the group. And then the last step would be to configure Docker, the Docker CLI, to run for non-root access without sudo. And here are the commands, right? This command was what you would have to run if the group didn't exist, but because it does, I don't have to worry about that. I have to run this command, though, to add myself, my current user, to the group, to the Docker group. So I'll run that command right now. And the last step is just to run this on Linux. This is one area where it's easier to do it on Linux than it is on Windows. If this were Windows, what I would have to do after executing the command in order to add myself to the group is I'd have to log out and log back in again. But on Linux, I just execute one command, this new group Docker command. And once I execute that, then I'm all set. Now I can come in and run Docker PS without needing the sudo command. And you see where before I got a permission error, now I have no permission problems. I can run any Docker command without needing to run sudo in front of it. So that makes my life a whole lot easier. It's one of the first things I always show whenever I teach a Docker class or give a Docker talk like I'm doing right now. All right, so here are some of the container details that you should be aware. So it's a normal OS process that executes on the local or remote host. It's isolated from the host with its own separate file system, networking, and process tree, and use the Docker run command to run an image inside of a container. And I just did that a moment ago when I ran that hello world example. Now, since we're going to dive into the commands now that I have everything installed, one of the first things that you need to know about with anything from the command line, in fact, any class that I teach on any technology where I'm doing command line work, the first thing I show people is the help. Because from the help, you can look up everything else, every other command that you might need to know about. There are 3 different ways that you can bring up the top level help with docker.exe. One way is you can just run Docker straight up with no other command line flags. And you see that it does give you the top level help. Another way is you can run Docker with -- help. -- help, like this. And that gets you to the same place. Or a third way is you can run Docker and run help without the -- and that will also bring up the top level help. So there are multiple ways to get to the same place, which is get to the top level help. Once you have the top level help, then you can drill down on the help to a particular command. Like I ran the PS command a moment ago, and how you bring up the help for that differs a little bit depending upon which one of these you want to use, whether you want to use help or whether you want to use -- help. If you use the -- flag, then, for example, I can run, let's bring up the help on Docker PS, Docker PS -- help. So run Docker, the command, and then for the flag, put in -- help. And now you're seeing the specific help with respect to Docker PS. All right, so that's another option. Or you can do this, which is Docker help, and then specify the command. So in other words, no -- but then specify the command that you want to bring up the help for, and that also gets you to the same place. So between the two, more a matter of which style you prefer. I'm more natively used to using -- help to bring up the help on an individual command. So you'll see me using that in the demos. But it's certainly a viable thing to run it the other way, where you say Docker, then the help command, and then after that, the command that you want to bring up the help for. Just remember the order is different depending upon whether you're using help or -- help. All right, now let's talk a bit about the details of running a container from an image. Ubuntu is actually containerized. Ubuntu itself has been containerized. So I can run the Docker image for Ubuntu by using Docker run Ubuntu. I'm going to do that right now, just so you can see what it looks like if I run this with no other flags. Right? That's the first thing I want you to see. Now, because this is the first time in this Docker installation that I am using the Ubuntu image, notice what you see is that it says that it's pulling the image and caching it locally, and then after that, it runs the container from the image. Now, how can you tell that Ubuntu is now installed in your local cache? Well, there's a command called Docker images that you can run. When you run that, you're able to see the images that are in your local cache, and these correspond to the 2 different runs that I've done with docker.exe. Remember, I ran hello world first, then I ran Ubuntu after that, and I didn't point it out at the time, but when I ran hello world, you saw something very similar. If you were looking really carefully, that it indicated that it was pulling down the image to your local cache. So very similar deal for what happened with Ubuntu. That happened earlier with hello world, and that's why you see both of them appear in your local cache there. Right? And that means on subsequent runs, for example, let's do that again. Let's run docker run Ubuntu. If I run that a second time, Ubuntu, then this time it will not say that it's pulling the image. It'll just run it directly from the image that is in my local cache. So there you go. It just comes right back to me at the command prompt. All right. Now, what's happening internally when I'm using this command, to the command I just ran there, docker run Ubuntu, is that the container runs immediately and then immediately exits. There's nothing that's occurring that's keeping that container around. Here's how you can see that. If you run that command I was talking to you, showing you a moment ago, docker ps, this will show you the list of running containers, and the key word is running. So when I run docker ps, you see nothing there, even though we've done 3 runs of containers up to now, right? I ran hello world, I ran Ubuntu twice, but nothing shows up when I run docker ps. And the underlying reason why is that they're not currently running. They've all exited. All 3 runs that I've done have exited. And here's how you can see that. If you run docker ps with the -a flag, then the -a flag will show you all containers, those containers that have exited, along with those containers that are currently running. So in other words, this will show you a superset of what you will see if you run docker ps with no -a flag. So if you look, there is the history of what I ran before. And if you look under the status column, it shows you that all 3 of these previous containers have exited. Right? So the question then becomes, well, if I'm going to run a container from the Ubuntu image, how can I make it stay up and running? Right? These flags right here are the key to doing that. So I want to show you each one of these flags in isolation, and I'll show you the combination of flags that will allow you to run the Ubuntu container from the image and be able to keep it around and be able to get a bash shell into that container subsequently. Right? So first one I want to show you is the -d flag for detached. This will run the container in the background. So let's do a run of Ubuntu with that exact flag, -d. I'm going to run it with no other flags. Typically, you wouldn't do this with no other flags especially for the Ubuntu container, but I want to show you each flag in isolation, like I was saying. So I'm going to run that, and docker run -d, and then Ubuntu. Got it in the wrong order on that run. Okay, there we go. So it comes right back to me, gives me the ID of the container. By the way, we're going to talk all about this in a few moments, but this is the ID of the container, very long form of the ID there. But if you look at what now happens when I run docker ps, still nothing there. If I run docker ps-a, then I see that Docker, that Ubuntu container that I ran a moment ago, it was created, but it exited. So it's still exiting, it's not keeping it around. Now, if I want to be able to run the Ubuntu image and interact with it, I can put in the -i flag. Right, so let me run it that way next. Come back around and do a Docker run with Ubuntu, but with -i. Now, I actually have, notice how it didn't come back to me at the main command prompt. I'm actually in the container with the ability to run commands against it. For example, I could run the ls command and see at the top level what inside of this container, what files and directories are there, right? So I can run commands against this, but this is not very friendly. So in other words, I can run something like pwd there. You can see I'm in the home directory, but it's not very user-friendly, obviously, because number one, when I ran ls, everything is all in individual rows. Every result is an individual row. It doesn't have the results spread across a row more nicely the way you would expect. And the second issue is I have no command prompt, right? So I'm going to exit out of here and get back to my main command prompt. I'm going to do a Docker run with -t, right? If I do Docker run -t Ubuntu, then I do get a command prompt. That looks a whole lot more friendly, right? But watch the problem that occurs here. When I try to run a command against it, nothing happens. And this is really bad because basically now I have no way to even exit this easily. So I'm actually going to SSH back in and kill that one, and then show you the right combination of flags so that now you've seen what these do in isolation, that you will be able to get a glimpse of, if I use all three of those flags together, then I get what I want, which is the Ubuntu container up and running. And now I can close this one up now that I'm back in. So once again, I'm going to run Docker PS to show you nothing's running right now. I'll run Docker PS-A to show you all of the ones that have exited previously. And I'm going to run this now the way I would ordinarily run it if I wanted to use a Ubuntu container and have it detached, have it run detached. So I'm going to do Docker run -IT and then -D and then Ubuntu. If I do that, then it comes back to me at the command prompt, but I can get back into that Ubuntu container, and when I run Docker PS, I can see it's running. And there you go, right? That I can see that I have running Ubuntu image created 9 seconds ago. It is up as of 8 seconds ago, right? So that is the combination of flags that you need to be aware of if you're going to run something like an Ubuntu container from the Ubuntu image that I have in my local cache, and you want to keep it running. That combination of flags will give you that capability. All right. Now, you saw this when I created earlier Ubuntu container, where it gave me back that really long-looking ID. That is one way to refer to that container, is by that ID. I don't know anyone who does it that way, though, because it's just too long and too unwieldy. So there's also a short form of the ID, which is what you see when you run Docker PS, for example. First column is that short form of the ID. Comparing it to this value, which is what I got back when I did the Docker run -IT-D on Ubuntu, that's the long form of the ID. You can use either one, like I said, to refer to that container when you run docker.exe, but I find certainly the short form is a whole lot easier to work with. Another option is either to name the container with your own name by using the appropriate flag when you run it, which is the --name flag, or to use the name that's assigned by default for that container, which is what you see in the names column when I ran Docker PS. So this names column, you see that this particular container was called romantic_Matsumoto. Now you might wonder, how are they generating that name? It's a combination of an adjective that's randomly selected, followed by an underscore, followed by the name of a scientist or hacker. So the details of how they generate that name aren't so important to you. The main thing that you need to know is if you want to subsequently refer to that container, then you can do so by using just the name that appears there. All right. Now, I find it a whole lot more convenient, though, if I do want to use a name to refer to it, and I'll run it again. I'll use exactly the same flags I used a moment ago, but I want to add one thing to this run, which is the --names flag. So I can say --name flag, I should say. Run it with --name, and then specify a choice, my choice of name, like my Ubuntu, a more meaningful name like this. Now it comes back to me when I run Docker PS. I should see in the last column for the latest run of the container that should be up and running because I ran it with -IT and -D. I should see in that last column my Ubuntu, and that's exactly what we have for this latest one. Okay? So that's a more convenient way. If you do want to refer to your containers by name, use that --name flag so that you can choose what the name is rather than relying upon the kind of humorous naming that they use there with the adjective, underscore, and the name of the scientist or hacker. I've shown you these first two commands, Docker PS and Docker PS-A. You've seen what they do and what the differences are between those two. Docker PS shows you the running containers. Docker PS-A shows you all containers, including those that have exited. Now that I have a couple running, let me rerun Docker PS-A so you're able to see the mix of those that are up. I have two that are up, but a whole bunch that have exited previously as well, right? And if you want to be able to see, for example, the full list of columns, then you can run Docker PS-A. In fact, let me just do it. Instead of trying to describe it, it's easier for me to just show you in a demo. So you can run Docker PS-A -no-trunk, which means don't truncate the output. And when you run this, you see the long forms of the IDs. Notice the big difference. Before, when I ran Docker PS-A, you were seeing the short forms of the IDs in the first column. Now you're seeing the long form of the IDs. So if you ever did want to see those long forms, Not that you would typically do that. That's what that --no-trunk flag is used for. And now I'm going to show you a very important command that's a setup for what I'm going to talk about in a few moments. And that's the docker ps-aq command. Let me go ahead and run docker ps-a again, so you see the short forms and everything is more nicely formatted for what you see on my command prompt. But if I wanted to be able to just get the container IDs listed, in other words, I don't want any of the other columns. I just want the container IDs. That's what this command, docker ps-aq, will give you. So you notice I'm just getting the values that are all in the first column. Now you might wonder, why do you care about that? Here's the reason why. If you want to apply a command to every one of what is in this docker ps-a list, by running it with the docker ps-aq, you get all of the IDs, which means in a single command, you can apply it to everything that you see in the list for docker ps-a. And you'll see when we use that in a few moments. All right. So just keep that command in mind. All right, so this is just a screenshot of what I've been doing in the demos. A docker run -d-it with Ubuntu, docker ps, so you can see it's up and running, docker ps-a, so you can see the list of all of the containers, including the ones that have exited, and then here's the no-trunk command, and then docker ps-aq. So that's all stuff that I demoed, and it's there, at least in the slides, so that you get an idea of how you can replicate those. All right, here are some major Docker commands you need to be aware of. If you want to stop a running container, let's actually do it. So I'm going to run docker ps so I can see specifically what's running. If I wanted to stop one of these, I can run docker stop. And this is where the name becomes very convenient. The fact that I've named it, then I can specify the name of the container as opposed to worrying about the ID. So I'm going to stop my Ubuntu like this. In a second. Not coming back to me very quickly. There it is. Okay, just a little bit slow. I'm going to do a docker ps command, and then I should be able to see that that no longer appears when I run docker ps. Remember, because docker ps is only going to show me the running containers. But when I run docker ps-a, then I should be able to see, if I look here, that the my Ubuntu exited because I stopped it. Right. And then there's also the option to start a stopped container. So I'm going to show you that one. I'll run docker start on my Ubuntu like that. And then it comes right back to me at the command prompt. That one's pretty quick to come back to me. When I run docker ps, I expect to see it in the list. And there it is. That my Ubuntu is now back. It's much quicker, instead of stopping a container and having to restart it, to pause it if you just want it to stop running. So you can do docker pause and my Ubuntu. Good. There we are. And now when I run docker ps, it does show up still because it's technically a running container, but it's in the pause state, and you can see that under the status column. And then if you want to unpause it, you just run the unpause command. Unpause on my Ubuntu like that. And then when I run docker ps, then you're able to see it's back into the up state, and it doesn't say paused anymore in the status column. So those are some of the other major commands that you need to be aware of. And this is just, again, a screenshot of what I was just doing in the demo seconds ago. Now, an important thing that you might want to know about is how do I remove a container, right? So the proper way to do it, I'll show you the proper way to do it first, is let me go to run docker ps-a so I can see one of the exited ones. Let's remove this oldest hello world one that I first ran initially. Then in order to remove it, I first should stop it if it's not already stopped. Well, this one's exited already, so I don't have to do that, but I'm going to run docker rm. And then since I didn't name this one, I'll just go by the ID. Or I can go by the name in the name column that they randomly assign me. But I'll run that command. When it comes back to you with the ID, that means it was successful. And when I see run of docker ps-a, I expect not to see that hello world one that I just removed a moment ago, and it is now gone. The only images we have are all the Ubuntu ones that I ran. But what if I want to stop a running container? Like these. Like to isolate on it, I'll just run docker ps so you can see the ones that are running. It will not work for me to do docker rm, which is the command that you use to remove that we ran a moment ago. But if it's a running container, it fails when I do a docker rm on, let me choose the one that I did not name, this one. All right. Notice how that fails. The problem is if the container is running, it won't allow me to remove it with rm. But what I can do is stop it first. This is one way to do it. So I'll stop the running container. So that would be In fact, I think I saw it on the clipboard. There we go. Docker stop to stop it. And once it's stopped, then I can remove it. And as you know, it takes a few seconds to stop it. So that's the story there. Now, if you do want to remove a container that is running and you don't have to stop it and then remove it separately, you can do this, although I don't recommend doing it this way, except as a last resort. Docker rm-f is the command you use to remove a running container. The reason I don't like that is that you are effectively blowing it away, and it could be in the middle of something, doing something that's important, right? And you have no knowledge about what state that is in, what it's actually running. So forcibly removing it is really a last resort thing, and I generally do not recommend that you do it that way, but I will demo it to you as well. All right, now that we stopped the container, this is the safe way. Do a stop it first, do a Docker RM on it, and now it's gone. Right. And when I do a Docker ps-a again, you would not see that Ubuntu one that we ran, which was identified by BBE. If you look in this container ID column, you do not see it there. All right. But since I do want to show you one run of this, as much as I hesitate to do that, then I will show you if I run Docker RM with -f on the one that I do have running, which is my Ubuntu, then this will blow it away in one go. And you see that it came back to me with the name right at the console there. And when I run Docker PS, nothing running anymore. And when I run Docker PS-a, you'll see no my Ubuntu. You look at the list of names in the last column. So that means I did successfully get rid of it. All right, let me show you a couple other ways to remove multiple containers. If you want to remove all stop containers in one go, so these are the containers I have that are all exited, right? Except for the one that says in the created status, but either way, they're not running containers at the moment. This is the command, Docker prune, that you can run, Docker container prune, I should say. And when I run that, it gives me at least a warning. Are you sure you want to continue? So you can think about it for a moment. I'm going to say yes, because I really do want to get rid of these. And then it gives me, again, the IDs of all the ones it got rid of. And I'm going to run Docker ps-a again. And I expect to see nothing in there. And I've blown them all away in one shot. All right. I want to show you one more technique. This is, again, one of those last resort things. It's not something I'm necessarily going to recommend that you use. The only reason I'm showing it to you is because it's really convenient for me when I'm demoing. If I want to get rid of both stop containers and containers that were not stopped, all right, so I'm going to do a Docker run hello world. I need some containers now because I have nothing. I'm going to do a couple of runs of hello world. I'll do a couple of runs of Ubuntu. Right? These are all ones that are going to be exited. And then I'm going to do a Docker run -d -it. So this one will not be exited. This will be running. Same thing here. And then I'm going to run Docker ps-a. So you can see the mix that I have of ones that are up. I have 2 that are up and 3 that are exited. What if I want to remove all of these in one shot, including the ones that are running? Then this is how I can do it. I can run Docker RM and -f. I got to use -f so I can get rid of the ones that are running, as I showed you earlier. And then now this command that I have to specify the command that I want to run that will give me the IDs of all of the containers, the container IDs. And remember that command I showed you earlier, Docker ps-aq. So if I run it this way, Docker rm-f, and we already know Docker ps-aq will give me all the container IDs, this will blow away everything in one go. There you go. And then when I run Docker ps-aq, I see nothing. So that's how you can forcibly remove all containers, including the mix of running as well as exit containers. Because the thing about Docker prune, container prune, is it'll only get rid of the stop containers, but any containers that are running, it will not get rid of those. Whereas this command will remove all containers, whether running or not. And the only reason I tend to use that is because I demo frequently like I'm doing now. And there are times when I just want to clean everything up in one shot. If you're not demoing though, and you're doing like real world usage of docker.exe, I don't necessarily recommend that you use that as a way of stopping containers for the reasons that I told you about earlier when I was introducing Docker rm-f. All right, so this is just, again, when I was doing the demo, it's there in the screenshot on the slide so that you can recreate what I'm doing if you would like to go back and consult the slides later. All right, now let me run this command again. The command I used to get a running Ubuntu container. There it is, right there. I'll run Docker PS. It is running, right? But what if I want to get back into that container and execute some commands against it? How can I do that? You need to know about this command. Docker exec -it is the command, and then specify the container name or ID. I'll just grab the ID from the first column because I didn't name this when I ran it. And then you just put in bash to indicate that you want to get a bash shell into the container. Right? So by running this command, now, even though I ran initially this container when I did the Docker run command with -d to run it detached, meaning it runs in the background, I can still get back into it by running Docker exec. So when I run that command, I get a shell into it. Now I can do an ls. I can see the list of files that are. I can do pwd to see what directory I'm in. All of that can be done by running that Docker exec command. And when I exit out of it, now when I run again Docker ps, see it is still up and running. So this is a really good way for you to run it in the background. Now when you need it, exec into it, get a shell into it, and then execute whatever commands that you need. And you can exit out of that shell, but still the container is up and running. So that's what the slide is mentioning right here. Right? So what I just did in the demo is basically the content of this slide. And then here's the screenshot again with the examples of what I was just doing a moment ago. All right, now let me see how we're doing on time. Oh God, I have just enough time to talk about images, how to create an image, how to find images out there on Docker Hub, and then the culmination of everything that I told you that I wanted to do, and I'm going to do it before the top of the hour, hopefully, which is to create a Node.js application, simple hello world app, containerize it, and then be able to run that container. All right. First thing you need to know about for creating an image is that it's specified using a Dockerfile. And an image is composed of a stack of what are called layers. Those layers represent instructions in the Dockerfile, and they represent the set of differences from the previous layer. And the reason why they use this layered approach is it allows them to reuse layers across images. And it's read-only except for the last layer, as I will show you in a picture that I have in the slides coming up. There's a single writable layer that represents the container layer. So image is totally read-only. The distinction between a container and an image is that the container has a thin, readable, writable layer on top, right? And here is the critical picture that illustrates that. So I'm going to just bring up the doc page from which this image comes. And if you scroll down in here, this is the place where you can read up a little bit more about this, but this is the key picture right here. So the way to interpret this picture is the fact that this gray box you see toward the bottom is the image. And the padlock indicates that it's read-only, right? You cannot write to these layers of the image. So the big things to know is the gray box, which represents the image, is composed of layers. Those layers are read-only, as indicated by that padlock there. And that also by the indication right here, the R/O indicates read-only. Then the distinction between a container and an image is a container is based on an image, but it adds this thin, readable, writable layer. So when in a container you are writing stuff out, where is that going to? It's going to that thin, readable, writable layer there. Right? So this is one of the most important pictures in this entire talk, because it'll give you an understanding of the distinction between an image and a container. I know when I was first learning this, you know, I could read all I wanted about the distinction between the two and how this works, but as soon as I saw this picture, it totally crystallized for me exactly how the architecture of image and container works. Right? You can have multiple containers that share an image, and each one of those containers, like for example, the demos I've been doing, where I've been running containers based on Ubuntu multiple times. What was going on there is for each one of those containers that I ran against that Ubuntu image, they each had their own thin, readable, writable layer, but they were all sharing the same read-only layers of the image itself. And this picture, again, comes from the doc page that I was just referring to a moment ago, same place where this image comes from. All right, now I mentioned Docker Hub earlier. Now I want to actually show you Docker Hub specifically, and here's the link to the Docker Hub page. This is provided by Docker. This is the place to go to in order to find the images that other people out there have made available. So I'm going to sign in with my appropriate credentials here. And actually, you know, I think I won't have to go through the sign-in process if I use Chrome, because I believe it's cache. So let me go to a Chrome browser here and go to that same place, just to speed things up a little bit. hub.docker.com. Okay, I'm running both Edge and Chrome, and it's not cached in the Edge version of the browser, but in the Chrome one it should be. And that way I can avoid, yeah, that's exactly what I want. So this is my personal Docker Hub account. So if you want to play around with this, you would need to sign up with Docker Hub, because the first time you come in, you obviously won't have a login, so you're going to have to sign up. And by the way, Docker, I'm always nervous about signing up to new websites. I don't like to sign up to too many of them because often I get too much spam, but Docker Hub's been really good. I mean, I've not had problems with them excessively spamming me or anything. So I don't really have any issues with telling you to come in, register for Docker Hub if you're new to all this. And one of the first things I want to show you is if you click on Explore, you'll be able to see the list of images that are out there. And remember, I was telling you earlier, there are over 9 million of them. You're seeing the exact number right there. And that's a moving target, by the way. Not long ago, when I was teaching the Docker and Kubernetes course that I wrote, that figure was around 8 million and something. Now it's over 9 million. So that gives you an idea of how widely used this technology really is. If you want to search for a specific image by a search term, then you can go to this search text box and just type in whatever that search term is. So to give you an idea, for example, of, let's take Nginx, of how many Nginx images that are out there, you can just type in the search term Nginx, and you'll be able to see from this list that there are over 104,000 images, 104,104 images out there that relate to Nginx. Right? By the way, if you have used Docker Hub in the past, I'll point out something that I just discovered today that is different, that they changed. It used to be the case if you wanted to see all the images, you could come right into this text box, put nothing in, and hit the enter key and see everything. They changed that now. If you try to do that today, this is what you get. Query must be at least 2 characters. So now what you have to do if you want to see everything is click on Explore, like I just did initially to get the image list. But you have to use this as a true search box. You cannot use it in a way to see everything because it's forcing you to put in at least a 2-character search term there. That's brand new. All right, the other bits though is I just want to show you from this first page that came up when I explored and found everything, how some of the major technologies that are here that are available as Docker images. And it's like a who's who of things that you've heard of. Nginx is right up at the top of the list there. There's Ubuntu Nginx. Here is, I think these are from the Nginx. These are coming from the Nginx search that I did. So I'm going to click back on Explore so I can just get, there we go. So see, these are the big ones I wanted to show you. These are generally arranged by popularity. So Alpine, by the way, Alpine is fantastic. If you're not familiar with what Alpine is, it is a Docker image based on Alpine Linux, which is extremely lightweight version of Linux, only 5 meg in size. It's incredibly small. All right, there's BusyBox. I'll scroll down a little bit more. Ubuntu, that was the one I was using. There's Redis, and just flipping through some of these Node. There's a Node.js. In fact, that's the one I'm going to use for the very final demo in this talk, culmination of everything. Hello World, that's the one I was using, very first demo that I did. There's Nginx right there, Mongo, and so on. I mean, I'll leave it up to you to peruse this, but I just want you to make you aware of, number one, how popular containerization is. Number two, that there are so many containers that are out there right now from folks who are using this technology, and you can leverage what is out there very easily. Now, one problem that you have if you're just getting started is browsing through some of this and, which ones should I look to use? Because you saw how many Nginx related ones there are. Let's go back to that, actually search for Nginx. And you see how many there are. Well, how do I know which one is a good one for me to base an image that I create on? Because whenever you create your own images, as we'll talk about coming up, you have to base it on some other image. Well, one easy way to do this is to look for the Docker official images, which you can restrict what you see to just those on the left hand by clicking on the left hand side there, right? So that's a really good technique. If you just want to see the official ones, I'm going to go back to where I was. So I'm seeing all the 104,000 Nginx ones. You might want to look for ones with verified publishers, so you can restrict that down by clicking there. And also even open source ones, there's a dedicated link for that. I'm going to go back to this official Docker image though for Nginx and click on it and show you what one of these pages looks like. And it has on the right-hand side the pull command that you can execute. So if you just want to pull it into your local cache, not necessarily run it, but pull it, then you can run this Docker pull command, and that will bring it into your local cache. This one's relatively bigger. And then when you run Docker images, you'll see it there. Because remember when I ran Docker images earlier in this talk, there was just Hello World and Ubuntu, but now when I run Docker images, there will be Nginx there as well, and there it is. So it's basically pulling it from Docker Hub into your local cache when you run that Docker pull command. If you look a little further down on this page, it'll give you some quick reference info, some supported tags and links. It'll talk about what Nginx is. Not all of the images that are in Docker Hub have this much verbiage about like how to use it, for example. Some of them are much more sparse. So I don't want you to be misled into thinking that every single one is going to have all of this, but this one is really a good example to use for something that has very explicit directions. But in any case, here, and including the licensing information at the back end there. So this is what one of these pages looks like up on Docker Hub. And then I want to show you this while I'm showing you Docker Hub. If you click on the repositories link, you can create your own repository. So if you notice, I've created a few repositories in my own login. I created this Microsoft repo when I was demoing I was teaching this class actually for Microsoft recently, the Docker and Kubernetes class. That's why I created this Docker repo. And I pushed some images up there. And here's if you go to this page, an example of how to do a push. In fact, it tells you the command to execute, how to push an image that you create up to your repo that you create in the Docker login that for Docker Hub. All right. Going back to this repositories page for a moment, I want to show you one other thing. If you want to create a new repo, just click on that create repo button right there, and then specify the name for the repo. And you can also choose whether you want it to be public or private, as you are seeing here. Okay. So that's the brief introduction to Docker Hub. Let me get back to where I was. So this is a screenshot of the Docker Hub website. And I want to make you aware of something else, that up in Azure, there's something called the ACR, or Azure Container Registry. And this is a private container registry that supports Docker, and more generally, something called the OCI, or Open Container Initiative. And one of the things that you want to have if you're going to create a registry is some of the same features that you get, for example, with your storing anything up in Azure. Geo-replication, there's automated build and updates for containers available. This is also integrated with Azure Active Directory Security through RBAC, Role-Based Access Control. All right. In a subsequent talk, I'm actually going to demo the Azure Container Registry. I don't have time to talk about it much here, since this is intended to be an introductory Docker talk, but I do want to make you aware that in Azure, there is a registry there that's kind of somewhat similar to the one I was showing you up there in Docker Hub. All right, so here are some of the image commands for the local repository. I've already shown you Docker images to show the local images that you have. There is Docker pull. I showed you that one a moment ago, to pull an image from Docker Hub to your local cache. And I'll show you Docker RMI if you want to remove one. You should at least see that quickly in a demo. So I'm going to run Docker RMI against hello-world. And then once I do that, see how it shows me the layers there that it's deleting. And then when I run Docker images, I see that it's no longer in my local image cache, right? And here are the image commands for the Docker Hub repository. You use Docker login to log into the repo from the command line. You need to tag your local image. I'll talk about tagging when I create my image in the demo I'm going to do at the end. And then push the image, use Docker push command. You already saw me do Docker pull. And this is the format where you indicate the hub name, hub username, and then the repo name, colon, and then the tag name that you specify. All right, let's get into what I said I wanted to do. Hopefully, about a little more than 10 minutes to do this before we get to the top of the hour, which is I wanted to show you how you can create and run an image. And that is specifying a Docker file that contains the instructions for building the image. If you want to have things that can be recreated by running commands that don't need to be part of the image itself, that's where you would use Docker ignore. And then to build the image, you need to build the image, then inspect it. If you wanted to inspect it, you can run Docker image inspect, and then ultimately run the image. These are the main commands that are related to creating and running an image. So let's talk a bit about the Docker file format. Actually, thinking about it, how much time do I have, by the way? Mike, if you want to chime in, can I go to the till 30 after the hour, or do I need to be done at the top of the hour?
You can keep going.
Okay, thanks, Martha. Yeah, okay, so I have more time than I thought. Good. Because I really want to, this is the culmination of everything, is the demo I'm going to do right here, where we're going to create an image and be able to run a container based on that image. So the Docker file format is where you have within the file instruction followed by the arguments for that instruction. The instruction needs to be in all, by convention, should be in all caps, right? It does not have to be, but that is the general convention, is to make the instruction part be all caps. And the arguments follow. It must begin with the from instruction that specifies the parent image on which the image you are creating is based. If you want to put a comment into a Docker file, you do so by using #. And if you have a long line and you want to do a line continuation, it is \. So that's the basic syntax for the Docker file format. Here's some of the main Docker file commands. The run command executes the commands in a new layer and commits the results. CMD, that command, specifies the command that you want to run within the container and provides defaults for executing the container. And then the label command is a key value pair. You add metadata to an image, and the reason I put this last bullet on this slide is that I've seen older examples, and you may encounter this if you like Google around for Docker file samples, where they use the maintainer instruction. That is considered deprecated. You should be using label instead, right? So maintainer is basically a way for you to indicate who the maintainer of that image is, right? So often ends up being the author of the image. Now this is one of the ones that is sometimes most often misunderstood, and that's the expose instruction. This specifies the ports on which the container listens at runtime if, for example, you're building something like a web server. Now, very important thing to know about this. It doesn't actually publish the port or make the port available externally. All right. This really acts as a form of documentation. You use Docker run -p if you want to publish or map ports. But the expose instruction within the Docker file is not for that purpose. The first time I ever saw expose used in a Docker file, I thought, oh, that's the one that's actually publishing or mapping the ports. It's not, right? Like I'm emphasizing this in particular because of the frequent misunderstanding of what expose does. Like I say, it's really more of a form of documentation. And then there's the add or copy instructions, which copies new files or directories from the source and adds them to the file system at the destination of the container. The best practice is to use copy for most situations and use add for example, if you want to create a compressed file, like a local tar file auto extraction, then that's where you would typically use add. All right, so this is what I said I was going to do at the end of this talk, which is to containerize a Node.js application. So we're going to do these steps. Create the Node.js files that are necessary, and this comes from a hello world example. Then we're going to build a custom Docker image based on that Node.js application. And then we're going to take that image and run a container based on it. And then we'll test it by using the curl command. Right? That's the plan. All right, so here is breaking down those steps, the Node.js part that I need. I need a server.js file and a package.json file. This example that I'm using comes, and I always like to give attribution for where I'm getting examples or diagrams from this web page. Note that this comes from Node.js. It also gives you an indication of how popular Docker is, given the fact that this is not Docker documentation. This is Node.js documentation where they're telling you how to take their technology and Dockerizing. So this example is about Dockerizing a Node.js web app, and they have the example here. I slightly modified it though, so you should be aware it's not exactly the same thing as their example. And I like to use this example for the purposes that we're going to use it for here, which is to show you how to Dockerize a Node.js app. Then what I'm going to do in a subsequent talk where I talk about Kubernetes is take the image I create here and actually deploy it up to Kubernetes. That won't be today, but if you're going to attend the future talks I'm going to be giving, I will be using the same demo, but taking it one level further after creating the container, then we're going to put it up into Kubernetes. So here is the server.js file. Now, a couple things I need to do here. One is I need, of course, some editor to work with where I can take this content and put it out to a server.js file, but on my Ubuntu VM. All right, since I have the time, I'm going to show you something I think is very, very cool. I could use the local editor here. For example, I could use VI, which I'm very comfortable with. Back in my grad school days and undergrad days, I used VI very frequently. So I still remember all those commands, but I'm more of a Windows guy now than I am a Unix or Linux guy. So that's why I'm much more frequently use Visual Studio Code. So what I'm going to do is use code as my editor and show you what I think is one of the coolest things that you can do with code, which is I'm going to be able to edit files on the remote SSH session that I established at the beginning of this talk, but using code running locally. That's the significance of what I'm about to show you. Now, to give you an idea about code, just a brief digression on code. I love code. I think code is a fantastic development environment for just about everything. I've been working with code for years, and when I first started working with it, I used to tell people, you can get code to do anything you want it to do if you're willing to sit there long enough and configure it. Well, I don't say that anymore. And the reason why I don't is that there's extensions available for just about every major technology that you want to use code with. And I work with a whole bunch of different technologies. So I'll tell you, I use code for all development that I do with a couple of exceptions. .NET development and C++ development, I still do that in Visual Studio as opposed to Visual Studio Code, just because of the fact that it's slightly more convenient in certain areas to use Visual Studio for those two forms of development. For literally everything else, though, I use code. And you can get a glimpse of how much I use code by looking at the extensions that I've installed. So right here, you can see the list of extensions that I personally use. Anaconda, I do a lot of machine learning and AI. So I installed the Anaconda extension for working with Anaconda. Here's a very big technology, a very large percentage of my life, especially lately, is Azure AD VC. So I've installed the extension for that. There are extensions for C++. So you can certainly use Visual Studio Code for C, C++, or C# development. In fact, in the .NET 6 course that I wrote, I do one demo of using Visual Studio Code to write .NET 6 code and debug it. And I will tell you, the debugging experience in Visual Studio Code with this extension is every bit as good as the experience that you would have in Visual Studio. All right. But anyway, let me get to the point of what this talk is about. I want you to know there's a Docker extension as well. Very convenient extension. There's also Jupyter Notebooks as I flip down. This is a machine learning related one, because the machine learning classes I teach, I need for that. Python as well, I use that for machine learning. Notice this is an extension for Kubernetes. All right, and I should mention this too, Docker extension very briefly, because this is a Docker talk, that it comes from Microsoft. This is not from some random third party out there on the internet. This is from the mothership itself, the same company that's producing Visual Studio Code. They're the ones who are making this Docker extension available. So the reason I'm pointing that out is some people are nervous about using certain extensions, and justifiably so, because if they come from random third parties, it might make you somewhat nervous. But like the Docker extension, totally safe to use because it's coming from Microsoft. Now, the one I want to show you in particular is a remote SSH extension. First time I saw this, my jaw dropped about how cool it is. This is going to allow me to do what I said I wanted to demo, which is that I'm able to edit files here on this Ubuntu VM that I'm SSH into using code running locally through this extension, this remote SSH extension. Here's how to use it. So my goal is to ultimately take this server.js file, put that out here to this Ubuntu VM, but I'm going to use code in order to do it. So you can either hit F1, as if you have this extension installed, you got to install this extension first. Once you have it installed, you either hit F1 or you click on this green button in the lower left corner, which says open a remote window. All right. Then with what comes up, you need to choose that you want to connect to host right there. All right. So I'll choose that one. And then you specify here the same info that I specified when I did the SSH session initially from the command line. So I'm going to find that from the portal because I don't have that in my clipboard anymore. So I'm going to go to the Azure portal, which was in this browser right there. All right, and oh, in fact, it's right in front of me. Okay, then I'm going to paste that right into here. All right, and a new Visual Studio Code session will pop up. And then in a few seconds, it'll ask you what OS you want to use, and I'm using Linux, so I'm going to choose Linux there. Once I choose that, then we wait a few, oh, and then it asks me for my password. So I'll put my password in. Same password I used to SSH in initially to the Ubuntu VM. And then wait a few seconds for it to, there we go. Now, one thing I don't like about the UI for this is it doesn't give you much visual confirmation that it worked. What you have to know is look in the lower left corner, the same spot where you initially clicked on the first Visual Studio Code instance to bring this up to begin with. If you look there, then it will say SSH and the IP address for the SSH session that you connected to, and that's how you know that it worked. All right. Then the next bit is just click right here for the Explorer, say Open Folder, and then you have to, this will by default try to take you to your home directory. That's totally fine. Just say OK. Now, the first time you do this, it's going to ask you in a second, you want to approve this. And it's going to ask you for your password a couple of times. Well, but it's doing that connection now. And see, it sets up the SSH host appropriately. All right, it's going to ask me for my password. So I'll put that in. So you do have to put in your password a couple of times. And then this is the dialog I was referring to a second ago, that the first time it's going to ask you, do you trust the author of the files in this folder? Since it's my own stuff, I'm going to turn on the checkbox so it won't ask me again and then say yes. And then I'm in. And at this point, I have a connection to that Ubuntu VM that I spun up at the beginning of this talk, but I'm able to edit all the files with exactly the same experience as if I were working completely with my local file system. It's beautiful. That's why I said the first time I ever saw this, my jaw dropped about how cool this is, because I've been working with Visual Studio Code for years, but only on the local file system, and wasn't even aware until I started working, until I found this extension, that you could do this, that you could actually edit files remotely, but working locally with almost exactly the same experience. Really, the only thing you'll notice on occasion is very slight lag, which is to be expected, but very, very slight, not to a level where it's disruptive at all. Okay, I'm going to create a new folder here where I'm going to put this Docker demo. See, I don't have to worry about using the Unix or Linux commands for creating the folder. Not that that's hard. I mean, make dir is not a big deal, but the nice thing is it abstracts me away from all those commands. And the reason why I had to learn this, by the way, is I was teaching the Docker Kubernetes class, actually, to a group of developers who are all Windows folks. So they were not that familiar with Linux. And we were running the class through an Ubuntu VM, just like I'm using for this demo. And so to relieve them of having to learn all the ins and outs of some form of a Unix editor, they were the ones that actually showed me this first. And once I discovered this, I said, wow, that is really cool. But I go back and forth. Sometimes I'll use the local Unix editors, just do it with VI, or sometimes if I have time, like sometime in this demo, then I figured I would show you that because I think it's so cool. Okay, now let's create a new file. So I need to call this file, by the way, server.js, since that is what I'm going to refer to it as in the Dockerfile that I'm going to be bringing in a few moments. Okay, so let me get back out to PowerPoint where I can copy all of that code so I don't have to type it all in and put it into the server.js file. It's pretty straightforward, standard code that you're seeing there for a hello world server. Basically, any request that you bring into this server is just going to send right back the string hello world. That's all we care about. Something very, very simple here is all we're trying to do. Okay. Then next bit is I want this, the package.json file. Of course, if you're working with a technology like Node, you'll need to have a package.js file to indicate the libraries that you need to bring in. So I'm going to put in a file called package.js like that, and save this all away. And I think you guys, if you're familiar at all with any of this, you should be able to read that and generally figure out what that is and how it works. One thing that's making me a little bit nervous is it looks like some characters are coming in from PowerPoint that this is not happy with. Oh, I thought I cleansed all that. You know what I may need to do? I think this may be, well, I'm going to go ahead and go. Oh, I know why. I think I misnamed the file. Package.json is what it should be called. I was thinking of the server.js. So there we go. Package.json. And now those errors are going away. I have the wrong extension on the file. Okay. Next up is I got to build the custom Docker image. So I'm going to need a Dockerfile. And because of the fact that I do not want to encompass into the image all of the node modules folder content, because it can be recreated, right? You can just run npm install to recreate it. Doesn't make sense to incorporate the node modules folder into the image. So I'm going to indicate through a .docker ignore those items that I do not want to be part of the image. That's what .docker ignore is for. All right. Then after that, we're going to build the image, and we'll get into the details of how to build it after I get these files in place. I'm going to create a file that I'm going to call Dockerfile with a capital D. I mentioned that earlier, but now here's the spot where it really matters because it's where we're creating it. You can tell that you got it right, by the way, too, because notice how the Docker extension that I brought into Visual Studio Code, because of that extension, if I name the file Dockerfile correctly, notice how that icon on the left side looks like a ship icon, which is the standard icon for Docker. So that's telling me that I generally have the right naming there. And then I'm going to paste that content right into here for the Docker file. Now, I want to go over this content a little bit with you as I bring it in. So what this is doing is first indicating that we're basing this image on the node image. That's that first line. This just sets the app directory. And then here is the part to install the app dependencies by using the copy instruction, right? So that's the package.json file that I created. It's just copying that to the local directory. And then we're going to do an npm install, a run of npm install, which will install the libraries. This is why, by the way, we don't need node modules encompassed into the image, because we're going to run this command npm install inside of the image, inside of the container, and that will bring in all the files anyway, right? And then copy the contents locally, and then expose. This is, remember, more of a form of documentation. And then the last thing is run this command, run node on the server.js file. All right, so that's what's going on there. Pretty readable, I would say, if you're familiar with the basics of how to create a Node.js server. This is a pretty simple one. All right, next up is the Docker ignore file. I told you that we were going to want to exclude from the image the node modules content. We're also going to exclude the npm debug log as well. So I just need to create a file here that I'm going to call .docker ignore. And notice as soon as I type that in completely, that icon changes well to a Docker icon. So that, again, is telling you that you got the naming generally right, at least so that it's recognized as being Docker related there. All right, so there's my content there. And now I need to go and execute the Docker build command. That command is Docker build, and then any options, the path to the Docker file or the URL to the Docker file, and that will set in motion the process of creating your Docker image. All right? And just a couple other notes while I'm on the slide. The context is a set of files that are indicated by the path or the Git repository URL. Those commands are set recursively to the daemon. It's best practice to start from a new directory that contains the Docker file and its dependencies. If you notice, I did that before starting up this demo. When I got into Visual Studio Code, once I established the connection, I created this Docker demo folder, since I know that that is best practice, right? And the Docker ignore file, as I went over, is optional, but you would want to put content in there that you don't want to include as part of the image. And certainly node_modules should be excluded for two reasons. One, the fact that it can be recreated easily by running npm install, which we're doing in the instructions. And number two, because it's big, right? Usually, when you're working with any technology, any JavaScript related technology, node modules ends up being the biggest part of your deployment. So it makes sense to exclude it from the container because it can always be recreated. Now let me go over with you the build command. In fact, I'm going to do this in the command line inside the Ubuntu VM. So let me get into the Docker demo folder right here. Do an ls to make sure, see all the files show up here. All those that I created in Visual Studio Code, they're all visible very nicely right here. And then this is the command I'm going to run. Docker build -t, like I'll do it right now. Docker build -t, and then no demo. And then the -t is to tag the image. So I specify the name, and then dot. And that dot is very significant, by the way. You need to, if you're going to run this command as I am now, you need to be in the directory where the Docker file is located. All right, that's key. So essentially, what I'm saying is build this Docker image, calling it no demo, and find the Docker file from the current directory. That's how to read that last dot there. So I'm going to run that, and it indicated, oh, I must not have done save. Yep, that is an important piece. You do need to save the file, and now it should have the right content. Let me run it, and you see it. First thing it does is it pulls the node image locally, and then from there, it is establishing, downloading all the layers, and this will take a few seconds because that node image is pretty big. So it has to extract the parts, the layers of the node image, and then once it's extracted them, then the pull will have been complete. It's a 7-step process. Again, I don't like to sit there idly just waiting for it to complete. So while that's running, I will go on and talk about how to do a Docker run, which is the next thing I'm going to do after the image has been successfully created. I'm going to run Docker run -d to run the container detached in the background. You've seen that command before. -p, and remember, I did mention this command, but you're actually going to see it here. This is how I'm going to be able to specify the binding of the ports. So I'm going to say 127.0.0.1:80:8080. So this does the port mapping, and then the name of the image, which will be no demo. Right, so let me wait till, okay, so that looks like it finished. So that's all good. All 7 layers or 7 steps are done. We should be able to see the image when I run Docker images. It should be there in my local cache, and there it is. Node demo right there. All right. So now the next step is to run this exact command that I have on the slide there, that Docker run command. And then the final thing is to curl it and see if we can actually get to it. So I'm going to do Docker run, and that way you know it's functionally working. -p, -d, -p, and after that -p, I want to put in the local machine 127.0.0.1, and then colon, and I'm going to do the mapping between 8080 and 80. Right? And then the last thing is no demo. All right, so that now creates a running image based, a running container based on the image, custom image that we created. I'm going to do a Docker PS command, and I expect to see that there is a no demo container that is running. And the last thing to do is to curl to localhost like that, and there's your hello world coming back. So that's the culmination of everything. I can tell that that's working because I just hit port 80, right? I didn't have to specify :80 because it defaults to that. And I did the mapping between port 8080 and port 8080 being what the Node.js code was listening on, and 80 being the port that I'm actually hitting when I from curl. And there's the hello world coming back. So that's an example of, like I said, the culmination of everything in this talk, where I wanted to show you how you start from nothing. In fact, we literally started from nothing in this talk, right? I started from creating the Ubuntu VM, installing Docker into it, then going and showing you the various Docker commands after the installation, showing you a little bit about the architecture of Docker container and image, and then getting into how you can do something more functional with it. And just to review what we did in the last few minutes, I showed you how to, the format for a Docker file. I showed you how to take some code, like Node.js code, from a simple sample, hello world code, this code right here, and how to containerize it in a Docker container, and then build an image based on that container, our own custom image right here. And then after that, last thing was build a container based on that image, or run a container based on that image, and then prove that that running container is actually acting as a Node.js server. By when we curl it, we are getting that hello world string back. And back to the code for the server.js file here, you see that for any request that comes in, we're just returning back hello world. All right. So that is the story of what I wanted to show you in this module. And this is just a little bit about that curl command that I ran. If you're not as much of a Unix person and not used to doing curl, then this is a command line tool for transferring data. It uses an URL syntax and supports a wide range of network protocols. So here's an example of how to run it. And this is just a summary of some of the main Docker CLI commands. So that, and you've seen me use every one of these actually in this talk. Docker run, which is used to run an image based on a container, run a container based on an image, excuse me. Docker pull, to pull an image from Docker Hub into your local cache. Docker build, to build the Docker image. I ran that at the end of this talk. Docker images, to see the list of available images in your local cache. Docker PS, I was using that throughout the talk, and PS-A. PS shows me the list of running Docker containers. PS-A shows me the list of all containers. Docker exec was the command to execute a command within a container that is running, but running detached. And Docker stop, to stop a running container. And Docker RM, to remove a container. Remember, best practice though is stop the container and then remove it. But if you really want to kill it, you can run Docker RM-F. So to wrap everything up, here are some of the big advantages of Docker and why you might want to think about using it. Standardization is one of the big advantages, right? That you see how much momentum there is behind Docker. The fact that I showed you in Docker Hub, there are over 9 million images out there. And I showed you in Docker Hub some of the major technologies you've at least heard of, and probably many of those you've been working with are containerized. And one of the things that I've learned in my 30+ years in the software development business is that you want to go with technologies that have a lot of momentum behind them. Even though you may like a particular technology, if it has no momentum behind it, then it's not really likely that you're going to be able to make a good career out of that. Whereas with Docker and containerization, there's so much momentum behind it and so much enthusiasm for it. That is a really good sign for you potentially looking to use it in whatever projects you are working on. Sharing is a big aspect too. I showed you how in Docker Hub, I can use other people's containers that are visible there. And likewise, you can write your own images and push them up to Docker Hub, either publicly or privately, and make them available to other people. Portability, I highlighted that as a big example of why Docker is important. The fact that I can take a container and run it on my local machine like I just did. And now if I wanted to take this container that I just created and run it in the cloud, which I will do in a subsequent talk, very easy to do. I don't have to make any changes to the container at all other than I didn't tag it completely. But that's the only change I'd have to make. I can literally use what I created here and lift and shift it right up into Azure with AKS and Kubernetes, which I will literally do in a subsequent talk. All right, and you can run it locally, you can run it in the cloud, you can run it on a VM, you can run it on dedicated hardware. All of that can be done with making minimal or no changes to your Docker, to the Docker image and container that you create. And if you use Kubernetes in conjunction with this, you have scaling. And of course, as I mentioned, Docker is very lightweight as opposed to containers in general are very lightweight as opposed to VMs. And this is the catchphrase. If you go to the Docker website, I'm going to go right to there just to conclude this talk. The main Docker website, docker.io, right here. I want you to see their catchphrase, which is build, run, and share. See, there's the build part, there's the share, and there's the run. That is what Docker is really about. It enables, that's a very good catchphrase. It enables developers to build, run, and share. And this is another phrase that they use: build safer, share wiser, and run faster. And I would say Docker very much accomplishes that. All right, that is it for the talk. There's a bit of time left over, about 13 minutes or so. Any questions from folks? And Martha, how do we do the questions? Do we open up the mics, or do you want to read me what's in the chat? Because
yep, Mike put the questions that came in so far. So anybody who has more, please put them in the chat window or the question window.
Okay, let me see if or are you able to see it? Because I'm having trouble going back through it.
Nope, it doesn't look like there's any unanswered questions.
No unanswered questions. Okay. All right. If not, then.
Now there is. Hold on. Danny's got
Okay.
a question.
Okay.
Can I run Docker on Windows without using Docker for Windows, in quotes?
No, if you want to run it natively on Windows, then you would have to, well, there's two options. One, you can use Docker for Windows, but your question was, can I run it without that? The answer is, there is a way to do it. What you can do is you can do it through a command prompt like I'm doing now, right? So in other words, you can use this, the Ubuntu app. So this, I don't know whether you consider this to be Windows or not, but there's Ubuntu for Windows as an app. You can install that so that you don't have to SSH the way I'm doing, and then install Docker inside of there, and now you have it running locally on Windows. I'm guessing the spirit of your question, and please chime in, further into the chat if I'm not interpreting your question correctly, but I'm guessing what you want to do is run entirely locally. And if you're happy with running entirely locally, because you're going to do command line work with Docker no matter what, then you can do exactly what I just mentioned, which is to install the Ubuntu app locally on Windows, and then install Docker inside of there just the same way that I demoed here. And in fact, when I first started working with Docker, that's exactly what I did. That's how I know that that technique works and works well, is just do it that way. And then you're not reliant upon Docker for Windows at all. You're just going through that local Ubuntu VM, but you would not even need necessarily, to have an SSH connection to anything if you do it that way. The reason I did it this way, by the way, just so you know, is that I find it to be, if I'm going to work with a lot of command line work, and I'm going to be working with Linux one way or another, like an Ubuntu VM or Ubuntu, whether either locally or through a VM. One of the things I like about the VM approach, though, as opposed to installing the app, is that if I encounter any problems or issues, I can start all over again so easily. I just blow away the VM, just delete it from my Azure sub, because you saw I created it in Azure, and I just start right over again. It's harder to do that when you install some software locally on your machine. You want to, something gets corrupted or has a problem, you want to start all over. It's much harder to do that, right? Whereas with using an Azure VM like this, I can just spin up another VM, delete the old one, and reinstall everything, and I'm right back in business. And part of the reason I'm mentioning that is when I was teaching the Docker Kubernetes class for Microsoft a few weeks ago, there were some people who actually, we ran into some problems. And I just told people, it's not worth trying to debug it and figure out what the installation problems are. Just blow it away and start over. And that's what they did. A few minutes later, they were up and running again. So that's why I'm taking the approach that I am in this talk. Any other questions?
Yep, Jacob's got a question. What is your preferred way for running Docker in Azure? Just a VM on Ubuntu?
For Azure, yeah, exactly what I demoed here is the preferred way. That's exactly how I would normally do it. Like if you asked me to do some Docker related work, I would do it exactly the way I demoed here. However, now here's the next bit of it. Depends on what I'm doing with the Docker containers. One important thing that I should make you aware of, which I don't have time to talk about in this talk, but we will cover it very thoroughly in subsequent talks, is almost everybody I know who uses Docker or containerization more generally does so in conjunction with Kubernetes. Right? That is the big technology that goes hand in hand with containerization. In other words, this is like the first step toward where you ultimately tend to go in real world scenarios of using containers, which is in conjunction with a container orchestrator of some sort. And Kubernetes is a de facto standard for that. And when you start working with Kubernetes, then typically you're looking at deploying into AKS if you're going to work with Azure. And there, you still need to know some of these commands, but in terms of how you end up using it, it's a little bit different, right? So if you want to know more about that, then like I said, in a later talk, I'll be covering that very thoroughly. Is now taking the next level beyond this, taking your containers, deploying it up to Kubernetes, and then ultimately taking the Kubernetes deployment and putting that up to Azure, putting it up to AKS. So that's normally how, if you're asking me a real world scenario for how I would use all of this, that's how I would use it. But for the Docker part, yeah, if I'm just working with Docker, then I'm going to do this. Now, something else I should make you aware of, that if the real world way that I would do the Docker part of it, just strictly the Docker part, but in preparation for working with AKS, is use the ACR, the Azure Container Registry that I mentioned, and create the image locally. So either by locally, I mean either through an Ubuntu VM like this or literally locally on your local machine. Then you can push the image up to the ACR and then work and create your cluster in AKS and then communicate between the two. And again, that's all stuff I'm going to demo in subsequent talks. But under that scenario, you might end up working more with the command prompt that's there in Azure to do some of the administration of the setup that I just mentioned.
Hey, Ron. So this is Mike really quick. So I'll jump in there too. So from Azure, I posted in chat, there's a lot of different ways that you can run your containers. So, you know, Docker is kind of the base way of building your containers and one way of running them. But if you're looking for like a full platform as a service capability, there's many different options that we can run through. So if you reach out to your Microsoft account team, we can dig in because it really depends on what your application is trying to accomplish, what your goals are. Is this an enterprise solution? Is this a point solution? How many other container apps are you going to be running? So there's many different questions that we'd want to run through. So definitely reach out to us or even someone at Macera to go through and talk through some of those different scenarios. But I listed a few of them in chat there.
Oh, great, thanks. Any other questions?
No, I think that's it.
Okay. Just about in time. So about 5 minutes before the 1:30 time, or 1:30 Central Time where I am. Okay, I think we are all done then.
All right. Thanks, Ron.
Yeah, my pleasure.
Thanks, everybody.
All right, bye.
Bye.